Question number 1. For each sequence, find the next 4 terms. Number 1. 1, 2, 4, 7, 11 and so on. Here T1 is equal to 1, T2 is equal to 2, T3 is equal to 4, T4 is equal to 7, T5 is equal to 11 and so on. Therefore, T1 is equal to 1, T2 is equal to T1 plus 1, T3 is equal to T2 plus 2, T4 is equal to T3 plus 3, T5 is equal to T4 plus 4. Using this relation, let us find the next 4 terms. Therefore, T6 is equal to T5 plus 5 is equal to 11 plus 5, which is equal to 16. Similarly, T7 is equal to T6 plus 6 is equal to 16 plus 6, which is equal to 22. T8 is equal to T7 plus 7 is equal to 22 plus 7, which is equal to 29. And T9 is equal to T8 plus 8, which is equal to 29 plus 8 is equal to 37. Therefore, the next 4 terms are 16, 22, 29 and 37. For each sequence, find the next 4 terms. 1 upon 2, 1 upon 6, 1 upon 18, 1 upon 54 and so on. Here T1 is equal to 1 upon 2, T2 is equal to 1 upon 6, T3 is equal to 1 upon 18 and T4 is equal to 1 upon 54. If you observe all these terms carefully, you will notice that T2 is equal to T1 into 1 upon 3. T3 is equal to T2 into 1 upon 3. And T4 is equal to T3 into 1 upon 3. Using the same relation, we can find the next 4 terms. Therefore, T5 is equal to T4 into 1 upon 3 is equal to 1 upon 54 into 1 upon 3, which is equal to 1 upon 162. T6 is equal to T5 into 1 upon 3 is equal to 1 upon 162 into 1 upon 3, which is equal to 1 upon 486. T7 is equal to T6 into 1 upon 3 is equal to 1 upon 486 into 1 upon 3, which is equal to 1 upon 1458. And T8 is equal to T7 into 1 upon 3 is equal to 1 upon 1458 into 1 upon 3, which is equal to 1 upon 4374. Therefore, the next 4 terms are 1 upon 162, 1 upon 486, 1 upon 1458 and 1 upon 4374. Find the first 5 terms of the following sequences whose nth terms are given. Tn is equal to n cube. Here it's given that Tn is equal to n cube. For n is equal to 1, T1 is equal to 1 cube, which is equal to 1. For n is equal to 2, T2 is equal to 2 cube, which is equal to 8. For n is equal to 3, T3 is equal to 3 cube, which is equal to 27. For n is equal to 4, T4 is equal to 4 cube, which is equal to 64. For n is equal to 5, T5 is equal to 5 cube, which is equal to 125. Thus, the first 5 terms of the sequence are 1, 8, 27, 64 and 125. Find T11 in the following arithmetic progression: 4, 9, 14 and so on. Solution. In the given AP 4, 9, 14 and so on, first term A is equal to 4 and common difference D is equal to 9 minus 4 is equal to 5. We know that Tn is equal to A plus n minus 1 into D. For n is equal to 11 and substituting the values of A and D, we get T11 is equal to 4 plus 11 minus 1 into 5. Therefore, T11 is equal to 4 plus 10 into 5. Therefore, T11 is equal to 4 plus 50. Therefore, T11 is equal to 54.
Find the sum of first 11 positive numbers, which are multiples of 6. Solution. First 11 positive numbers, which are multiples of 6, are 6, 12, 18, 24, and so on up to 66. Here A is equal to 6, D is equal to 6, N is equal to 11, and the last term L is equal to 66. Therefore, Sn is equal to n upon 2 into in bracket A plus L. Now, substituting the values, we have S11 is equal to 11 upon 2 into 6 plus 66. Therefore, S11 is equal to 11 upon 2 into 72. Therefore, S11 is equal to 11 into 36, which is equal to 396. Therefore, the sum of first 11 positive numbers which are multiples of 6 is 396.
Find the first 5 terms of the following sequences whose nth terms are given. Tn is equal to n plus 2. Here, it is given that Tn is equal to n plus 2. For n is equal to 1, T1 is equal to 1 plus 2 is equal to 3. For n is equal to 2, T2 is equal to 2 plus 2 is equal to 4. For n is equal to 3, T3 is equal to 3 plus 2 is equal to 5. For n is equal to 4, T4 is equal to 4 plus 2 is equal to 6. And for n is equal to 5, T5 is equal to 5 plus 2 is equal to 7. Thus, the first 5 terms of the sequence are 3, 4, 5, 6 and 7. Which of the following list of numbers are arithmetic progression? Justify. 1, 3, 6, 10 and so on. Solution. Here 3 minus 1 is equal to 2. That is, T2 minus T1 is equal to 2. Similarly, 6 minus 3 is equal to 3. That is, T3 minus T2 is equal to 3. And 10 minus 6 is equal to 4. That is, T4 minus T3 is equal to 4. Here we can see that T2 minus T1 is not equal to T3 minus T2, which is further not equal to T4 minus T3. This shows that the difference between any two consecutive terms is not constant. Hence, the given sequence is not an arithmetic progression. Find the 18th term of the arithmetic progression 1, 7, 13, 19 and so on. Solution. Here we have T1 is equal to A, which is equal to 1. And T2 is equal to 7. T3 is equal to 13 and T4 is equal to 19. Therefore, D will be equal to T2 minus T1 is equal to 7 minus 1, which is equal to 6. As we know that Tn is equal to A plus n minus 1 into D. The 18th term, that is T18, is equal to 1 plus in bracket 18 minus 1 into 6 is equal to 1 plus 17 into 6 is equal to 1 plus 102, which is equal to 103. Therefore, the 18th term is 103. Find the first 5 terms of the following sequences whose nth terms are given. Tn is equal to n square minus 2n. Here it is given that Tn is equal to n square minus 2n. For n is equal to 1, T1 is equal to 1 square minus 2 into 1, which is equal to minus 1. For n is equal to 2, T2 is equal to 2 square minus 2 into 2, which is equal to 0. For n is equal to 3, T3 is equal to 3 square minus 2 into 3, which is equal to 3. For n is equal to 4, T4 is equal to 4 square minus 2 into 4, which is equal to 8. And for n is equal to 5, T5 is equal to 5 square minus 2 into 5, which is equal to 15. Thus, the first 5 terms of the sequence are minus 1, 0, 3, 8, and 15. For each sequence, find the next 4 terms: 2, 6, 12, 20, 30, and so on. Here, T1 is equal to 2, T2 is equal to 6, T3 is equal to 12, T4 is equal to 20, T5 is equal to 30, and so on. If you observe all the terms carefully, you will notice that T1 is equal to 1 square plus 1, T2 is equal to 2 square plus 2, T3 is equal to 3 square plus 3, T4 is equal to 4 square plus 4, T5 is equal to 5 square plus 5. Using the same relation, we can find the next 4 terms. Therefore, T6 is equal to 6 square plus 6 is equal to 36 plus 6, which is equal to 42. Similarly, T7 is equal to 7 square plus 7 is equal to 49 plus 7, which is equal to 56. T8 is equal to 8 square plus 8 is equal to 64 plus 8, which is equal to 72. And T9 is equal to 9 square plus 9 is equal to 81 plus 9, which is equal to 90. Therefore, the next 4 terms are 42, 56, 72, and 90. Which of the following list of numbers are arithmetic progression? Justify. 3, 5, 7, 9, 11, and so on. Here, 5 minus 3 is equal to 2. That is, T2 minus T1 is equal to 2. Similarly, 7 minus 5 is equal to 2. That is, T3 minus T2 is equal to 2. Further, 9 minus 7 is equal to 2. That is, T4 minus T3 is equal to 2. Also, 11 minus 9 is equal to 2. That is, T5 minus T4 is equal to 2. This shows that the difference between any two consecutive terms is constant. Hence, the given sequence is an arithmetic progression. Zero 0.5, 2, 3.5, 5, and so on. Solution. Here, 2 minus 0.5 is equal to 1.5. That is, T2 minus T1 is equal to 1.5. Similarly, 3.5 minus 2 is equal to 1.5. That is, T3 minus T2 is equal to 1.5. Also, 5 minus 3.5 is equal to 1.5. That is, T4 minus T3 is equal to 1.5. Thus, the difference between two consecutive terms is constant. Hence, the given sequence is an arithmetic progression. Write the first 5 terms of the following arithmetic progressions when the common difference D and the first term A are given. Number 1. A is equal to 2 and D is equal to 2.5. Solution. It is given that A is equal to 2 and D is equal to 2.5. Hence, T1 is equal to 2. Therefore, T2 is equal to T1 plus D. That is, T2 is equal to 2 plus 2.5, which is equal to 4.5. Now, T3 is equal to T2 plus D. That is, T3 is equal to 4.5 plus 2.5, which is equal to 7. T4 is equal to T3 plus D. That is, T4 is equal to 7 plus 2.5, which is equal to 9.5. And T5 is equal to T4 plus D. That is, T5 is equal to 9.5 plus 2.5, which is equal to 12. Thus, the first 5 terms of an arithmetic progression are 2, 4.5, 7, 9.5, and 12. For an arithmetic progression, if T4 is equal to 12 and D is equal to minus 10, then find its general term. Solution. It is given that T4 is equal to 12 and D is equal to minus 10. Also, we know that Tn is equal to A plus n minus 1 into D. Therefore, T4 is equal to A plus 4 minus 1 into minus 10. As T4 is 12, therefore 12 is equal to a minus 30. Therefore, 12 plus 30 is equal to a. Therefore, a is equal to 42. Its general term, that is Tn, is equal to a plus n minus 1 into d. Putting the values of a and d, we get Tn is equal to 42 plus n minus 1 into minus 10. Therefore, Tn is equal to 42 minus 10n plus 10. Therefore, Tn is equal to minus 10n plus 52.
Given the following sequence, determine whether it is arithmetic or not. If it is an arithmetic progression, find its general term. The sequence is minus 5, 2, 9, 16, 23, 30 and so on. Solution. The given sequence is minus 5, 2, 9, 16, 23, 30 and so on. Accordingly, we have T1 is equal to minus 5, T2 is equal to 2, T3 is equal to 9, T4 is equal to 16, T5 is equal to 23, T6 is equal to 30 and so on. Now, 2 minus 5 is equal to 7. That is, T2 minus T1 is equal to 7. Similarly, 9 minus 2 is equal to 7. That is, T3 minus T2 is equal to 7. Also, 16 minus 9 is equal to 7. That is, T4 minus T3 is equal to 7. Further, 23 minus 16 is equal to 7. That is, T5 minus T4 is equal to 7. And 30 minus 23 is equal to 7. That is, T6 minus T5 is equal to 7. Thus, the difference between the two consecutive terms is constant. Hence, the sequence is an arithmetic progression. Therefore, A is equal to minus 5 and D is equal to 7. Its general term is Tn is equal to A plus n minus 1 into D. Substituting the values of A and D, we get Tn is equal to minus 5 plus n minus 1 into 7. Therefore, Tn is equal to minus 5 plus 7n minus 7. Therefore, Tn is equal to 7n minus 12. Find the sum of the first n even natural numbers. Hence, find the sum of the first 20 even natural numbers. Solution. Here, the first n even natural numbers, A is equal to T1 is equal to 2. and D is equal to 2. We have Sn is equal to n upon 2 into 2a plus n minus 1 into 2. Therefore, Sn is equal to n upon 2 into 4 plus 2n minus 2. Sn is equal to n upon 2 into 2 plus 2n. Therefore, Sn is equal to n upon 2 into 2 in bracket 1 plus n. Therefore, Sn is equal to n into 1 plus n. Sn is equal to n plus n square. Now to find the sum of first 20 even natural numbers, S20 is equal to 20 plus 20 square, which is equal to 20 plus 400. Therefore, S20 is equal to 420. Therefore, the sum of first 20 even natural numbers is 420.
How many 3-digit natural numbers are divisible by 4? Solution. The 3-digit natural numbers which are divisible by 4 are 100, 104, 108, 112 and so on up to 996. These numbers form an arithmetic progression with first term, that is a equals to 100, and common difference d is equal to 4 and Tn is equal to 996. Now we know that Tn is equal to a plus n minus 1 into d. Substituting the values of a, d and Tn, we have 996 is equal to 100 plus n minus 1 into 4. Therefore, 996 minus 100 is equal to 4n minus 4. Therefore, 896 is equal to 4n minus 4. Therefore, 896 plus 4 is equal to 4n. 900 is equal to 4n. Therefore, n is equal to 900 divided by 4, which is equal to 225. Thus, there are 225 terms of 3-digit natural numbers that are divisible by 4.
Obtain the sum of the 56 terms of an arithmetic progression whose 19th and 30th term are 52 and 148 respectively. Solution. It is given that T19 is equal to 52 and T38 is equal to 148. Now, we know that Tn is equal to a plus n minus 1 into d. Therefore, T19 is equal to a plus 19 minus 1 into d. Therefore, 52 is equal to a plus 18d. Let this be equation number 1. Similarly, T38 is equal to a plus 38 minus 1 into d. Therefore, 148 is equal to a plus 37d. Let this be equation number 2. Now, Adding equation 1 and 2, we get 200 is equal to 2a plus 55d. Let this be equation number 3. Now, we also know that Sn is equal to n upon 2 into 2a plus n minus 1 into d. Therefore, S56 will be equal to 56 upon 2 in bracket 2a plus 56 minus 1 into d, which is equal to 28 into 2a plus 55d. Now substituting the value of 2a plus 55d from equation 3, we have S56 is equal to 28 into 200. Therefore, S56 is equal to 5600.
How many terms of the arithmetic progression 16, 14, 12 and so on are needed to give the sum 60? Explain why we get double answer. Solution. The given sequence is, therefore we have a is equal to 16, d is equal to 14 minus 16, which is equal to minus 2. And as per the given information, Sn is equal to 60. Now using the formula, Sn is equal to n upon 2 into, in bracket, 2a plus n minus 1 into d. Substituting the values, we have 60 is equal to n upon 2 into 2 into 16 plus n minus 1 into minus 2. Therefore, 60 into 2 is equal to n into, in bracket, 32 minus 2n plus 2. Therefore, 120 is equal to n into 34 minus 2n. Therefore, 120 is equal to 34n minus 2n square. Shifting all the terms, we have 2n square minus 34n plus 120 is equal to 0. Dividing by 2 on both the sides, we get n square minus 17n plus 60 is equal to 0. After factorization, we get n minus 12 into n minus 5 is equal to 0. Therefore, n is equal to 12 or n is equal to 5. If n is equal to 5, then the sum of the first 5 terms is 60. Therefore, sum of the first 5 terms is 60 and sum of the last 7 terms is 0, where they are opposite to each other. That is, they are equal in magnitude but opposite in sign. Question number 3. How many terms of the
Find the sum of all odd natural numbers from 1 to 150. Solution. The odd natural number between 1 and 150 are 1, 3, 5, 7, 9 and so on up to 149. Note that 149 is the last odd natural number. Here we have to find 1 plus 3 plus 5 plus 7 plus 9 plus so on till plus 149. So let the nth term be 149. That is, Tn is equal to 149. But 1, 3, 5, 7 and so on up to 149 forms an arithmetic progression with A is equal to 1, D is equal to 2 and Tn is equal to 149. By using the formula Tn is equal to A plus in bracket n minus 1 into D, we have 149 is equal to 1 plus in bracket n minus 1 into 2. Therefore, 149 is equal to 1 plus 2n minus 2. Therefore, 149 is equal to 2n minus 1. Therefore, 2n is equal to 150. Therefore, n is equal to 75. Thus, there are 75 odd natural numbers between 1 and 150. Now, the sum of 75 odd natural numbers, that is Sn, is equal to n upon 2 into A plus Tn. Therefore, S75 is equal to 75 upon 2 into 1 plus 149, which is equal to 75 upon 2 into 150 is equal to 75 into 75. Therefore, S75 is equal to 5625. Therefore, the sum of all odd natural numbers between 1 and 150 is 5625.
Question number 5. Find the sum of the first n odd natural numbers. Hence, find 1 plus 3 plus 5 and so on plus 101. Solution. Here, in the first n odd natural numbers, A is equal to T1, which is equal to 1, and D is equal to 2. Therefore, we have Sn is equal to n upon 2 into 2A plus n minus 1 into D. Substituting the values, we get Sn is equal to n upon 2 in bracket 2 into 1 plus n minus 1 into 2. Therefore, Sn is equal to n upon 2 into 2 plus 2n minus 2. Therefore, Sn is equal to n upon 2 into 2n. 2 gets cancelled out and we get Sn is equal to n square. Now, as per the given information, 1 plus 3 plus 5 plus so on plus 101. We have Tn is equal to 101. We also know that Sn is equal to n upon 2 into T1 plus Tn. Therefore, n square is equal to n upon 2 into 1 plus 101. Therefore, n square is equal to n upon 2 into 102. Therefore, n square is equal to n into 51. Now, n square divided by n is equal to 51. N gets cancelled out in the numerator and denominator, and we get n is equal to 51. Now, S51 will be equal to 51 divided by 2 into 1 plus 101, which is equal to 51 upon 2 into 102, which is further equal to 51 into 51. Therefore, S51 is equal to 2601. Hence, 1 plus 3 plus 5 so on plus 101 is equal to 2601.
The sum of the first 55 terms of an arithmetic progression is 3300. Find the 20th term. Solution. We know that Sn is equal to n upon 2 into 2a plus n minus 1 into d. It is given that S55 is equal to 3300. Therefore, S55 is equal to 55 upon 2 in bracket 2a plus 55 minus 1 into d. Therefore, 3300 is equal to 55 upon 2 into 2a plus 54d. Now, 3300 is equal to 55 upon 2 into, taking out 2 common, in bracket a plus 27d. 2 gets cancelled out and we have 3300 is equal to 55 into a plus 27d. Therefore, 3300 divided by 55 is equal to a plus 27d. Now, a plus 27d will be equal to 60. Let this be equation number 1. We also know that Tn is equal to a plus n minus 1 into d. Therefore, T28 is equal to a plus 28 minus 1 into d. Therefore, T28 is equal to a plus 27d. From equation 1, we know that a plus 27d is equal to 60. Therefore, T28 is also equal to 60. Thus, the 20th term is 60.
Find 4 consecutive terms in an arithmetic progression whose sum is 12 and sum of the third and fourth term is 14. Solution. Let the 4 consecutive terms be a minus 3d, a minus d, a plus d, and a plus 3d. The sum of the 4 consecutive terms is given as 12. Therefore, we have a minus 3d plus a minus d plus a plus d plus a plus 3d is equal to 12. Here, minus 3d and plus 3d gets cancelled out. Similarly, minus d and plus d gets cancelled out. Hence, we have 4a is equal to 12. Therefore, A is equal to 12 divided by 4. Therefore, A is equal to 3. Now, it is also given that the sum of third and the fourth term is 14. Therefore, we have A plus D plus A plus 3D is equal to 14. Therefore, 2A plus 4D is equal to 14. Putting the value of A is equal to 3, we get 2 into 3 plus 4D is equal to 14. 6 plus 4D is equal to 14. 4D is equal to 14 minus 6. Therefore, 4D is equal to 8. Therefore, D is equal to 8 divided by 4. Therefore, D is equal to 2. Now, putting the value of A and D, we get T1, that is first term, is equal to A minus 3D is equal to 3 minus 3 into 2 is equal to 3 minus 6, which is equal to minus 3. Similarly, T2, that is second term, is equal to A minus D is equal to 3 minus 2, which is equal to 1. Further, T3, that is third term, is equal to A plus D is equal to 3 plus 2, which is equal to 5. T4, that is fourth term, is equal to A plus 3D is equal to 3 plus 3 into 2, which is equal to 9. Therefore, the four consecutive terms are minus 3, 1, 5 and 9. A village has 4,000 literate people in the year 2010, and this number increases by 400 per year. How many literate people will be there till the year 2020? Find formula to know the number of literate people after n years. Solution. A village has 4,000 literate people in the year 2010. Hence, first term A is equal to 4,000 and this number increases by 400 per year. Therefore, the common difference D is equal to 400. Here, we have to find the literate people till the year 2020. That is, the number of literate people after 10 years. Therefore, n is equal to 10. We know that Tn is equal to A plus n minus 1 into D. Therefore, T10 is equal to 4,000 plus 10 minus 1 into 400. Therefore, T10 is equal to 4,000 plus 3,600. Therefore, T10 is equal to 7,600. Therefore, 7,600 literal people will be there till the year 2020. Here, we also have to find the formula to know the number of literate people after n years. Therefore, the formula is Tn is equal to 4,000 plus n minus 1 into 400, which is equal to 4,000 plus 400n minus 400. is equal to 3600 plus 400n. Therefore, Tn is equal to 400n plus 3600. Thus, the formula to find the number of literate people after n years is Tn is equal to 400n plus 3600. The sum of first n terms of an arithmetic progression is 3n plus n square. Then, number 1, find first term and sum of first two terms. Number 2, find second, third and 15th term. Solution. It is given that Sn is equal to 3n plus n square. Therefore, Sn minus 1 will be equal to 3 into n minus 1 plus n minus 1 whole square is equal to 3n minus 3 plus n square minus 2n plus 1. Therefore, Sn minus 1 is equal to n square plus n minus 2. Now, Tn is equal to Sn minus Sn minus 1. Substituting the values, we get Tn is equal to 3n plus n square minus in bracket n square plus n minus 2 is equal to 3n plus n square minus n square minus n plus 2. Here, plus n square and minus n square gets cancelled out. Therefore, we get Tn is equal to 2n plus 2. Now, the first term, that is T1, will be equal to 2 into 1 plus 2, which is equal to 2 plus 2 is equal to 4. Therefore, first term is equal to 4. Now, Sn is equal to 3n plus n square. To find the sum of first two terms, we have S2 is equal to 3 into 2 plus 2 square is equal to 6 plus 4, which is equal to 10. Therefore, sum of first two terms is equal to 10. Now, to find second, third and 15th term, consider Tn is equal to 2n plus 2. Therefore, T2 is equal to 2 into 2 plus 2 is equal to 4 plus 2, which is equal to 6. Similarly, T3 is equal to 2 into 3 plus 2 is equal to 6 plus 2, which is equal to 8. And T15 is equal to 2 into 15 plus 2 is equal to 30 plus 2 is equal to 32. Therefore, second, third and the 15th term are 6, 8 and 32 respectively. Find 4 consecutive terms in an arithmetic progression whose sum is minus 54 and the sum of first and the third term is minus 30. Solution. Let the 4 consecutive terms be a minus 3d, a minus d, a plus d, a plus 3d. The sum of 4 consecutive terms is given as minus 54. Therefore, we have a minus 3d plus a minus d plus a plus d plus a plus 3d is equal to minus 54. Here, minus 3d and plus 3d gets cancelled out. Similarly, minus d and plus d gets cancelled out. Therefore, we have 4a is equal to minus 54. Therefore, a is equal to minus 54 divided by 4. Therefore, a is equal to minus 13.5. Now, it is also given that the sum of first and the third term is minus 30. Therefore, we have a minus 3d plus a plus d is equal to minus 30. Therefore, 2a minus 2d is equal to minus 30. Taking out 2 common, we have 2 in bracket a minus d is equal to minus 30. Therefore, a minus d is equal to minus 30 divided by 2. Therefore, a minus d is equal to minus 15. But we know that a is equal to minus 13.5. Putting this value, we get minus 13.5 minus d is equal to minus 15. Therefore, minus d is equal to minus 15 plus 13.5. Therefore, minus d is equal to minus 1.5. Therefore, d is equal to 1.5. Now, putting the values of a and d, we get t1, that is the first term, is equal to a minus 3d is equal to minus 13.5 minus 3 into 1.5 is equal to minus 13.5 minus 4.5 is equal to minus 18. Similarly, t2, that is the second term, is equal to a minus d is equal to minus 13.5 minus 1.5 is equal to minus 15. Further, t3, that is the third term, is equal to a plus d is equal to minus 13.5 plus 1.5, which is equal to minus 12. Further, t4, that is the fourth term, is equal to a plus 3d is equal to minus 13.5 plus 3 into 1.5 is equal to minus 13.5 plus 4.5, which is equal to minus 9. Therefore, 4 consecutive terms are minus 18, minus 15, minus 12 and minus 9.
In winter, the temperature at a hill station from Monday to Friday is an arithmetic progression. The sum of the temperatures of Monday, Tuesday and Wednesday is 0, and the sum of temperatures of Thursday and Friday is 15. Find the temperature of each day of the 5 days. Solution. Let the temperature at hill station from Monday to Friday be a minus 2d, a minus d, a plus d and a plus 2d. The sum of temperatures of Monday, Tuesday and Wednesday is 0. Therefore, we have a minus 2d plus a minus d plus a is equal to 0. Therefore, 3a minus 3d is equal to 0. Taking out 3 common, we get 3 in bracket a minus d is equal to 0. Therefore, a minus d is equal to 0 divided by 3 is equal to 0. Therefore, we have a is equal to d. Now, the sum of the temperatures of Thursday and Friday is 15. Therefore, a plus d plus a plus 2d is equal to 15. Therefore, 2a plus 3d is equal to 15. But we know that a is equal to d. Therefore, 2d plus 3d is equal to 15. Therefore, 5d is equal to 15. Therefore, d is equal to 15 divided by 5. Therefore, d is equal to 3. If d is equal to 3, then a is also equal to 3. Now, we shall find out the temperatures from Monday to Friday. Number 1. A minus 2d is equal to 3 minus 2 into 3 is equal to minus 3. Similarly, a minus d is equal to 3 minus 3 is equal to 0. Number 3. A is equal to 3. Number 4. A plus d is equal to 3 plus 3 which is equal to 6. And a plus 2d is equal to 3 plus 2 into 3 is equal to 9. Therefore, the temperature of each of the 5 days are minus 3, 0, 3, 6 and 9.
In a school, a plantation program was arranged on the occasion of World Environment Day on a ground of triangular shape. The trees are to be planted as shown in this figure. One plant in the first row, 2 plants in the second row, 3 plants in the third row, and so on. If there are 25 rows, then find the total number of plants to be planted. Solution. As per the given information, 1 plant is planted in the first row, 2 plants in the second row, 3 plants in the third row, and so on, and 25 plants in the 25th row. The number of plants in the rows 1, 2, 3 and so on up to 25 are in arithmetic progression, with the first term T1 or A is equal to 1 and the 25th term T25 is equal to 25. Now to find the total number of plants, that is S25, we have to use the formula Sn is equal to n upon 2 into T1 plus Tn. Therefore, S25 is equal to 25 upon 2 into 1 plus 25, which is equal to 25 upon 2 into 26. Therefore, S25 is equal to 25 into 13, which is equal to 325. Therefore, the total number of plants to be planted is 325. Neela saves in a Mahila Bachat Gat ₹2 on the first day, ₹4 on the second day, rupees 6 on the third day, and so on. What will be her saving in the month of February 2010? Solution. It is given that Neela saves in a Mahila Bachat Gut rupees 2 on the first day, rupees 4 on the second day, rupees 6 on the third day, and so on. Therefore, the saving 2, 4, 6 and so on are in arithmetic progression, with the first term 2 and the common difference 2. Now, we know that the number of days in the month of February is 28. Hence, n is equal to 28. Now, to find her saving in the month of February 2010, we have A is equal to 2, D is equal to 2, and N is equal to 28. Using formula, Sn is equal to n upon 2 in bracket 2a plus n minus 1 into d. Substituting the values, we get S28 is equal to 28 divided by 2 in bracket 2 into 2 plus 28 minus 1 into 2 is equal to 14 in bracket 4 plus 27 into 2 is equal to 14 into 4 plus 54. Therefore, S28 is equal to 14 into 58, which is equal to 812. Therefore, Neela's saving in the month of February 2010 is rupees 812.
Find three consecutive terms in an arithmetic progression whose sum is minus 3 and product of their cubes is 512. Solution. Let the three consecutive terms be a minus d, a and a plus d. It is given that their sum is minus 3. Therefore, we have a minus d plus a plus d is equal to minus 3. Here, minus d and plus d gets cancelled out and we get 3a is equal to minus 3. Therefore, a is equal to minus 3 divided by 3. Therefore, a is equal to minus 1. Further, it is also given that the product of the cubes is 512. Hence, we get a minus d whole cube into a cube into a plus d whole cube is equal to 512. Taking cube root on both the sides, we get a minus d into a plus d is equal to 8. Here, according to the formula, a minus b into a plus b is equal to a square minus b square. We have a into a minus d into a plus d is a square minus d square is equal to 8. But here we know that a is equal to minus 1. Therefore, putting this value, we have minus 1 in bracket minus 1 square minus d square is equal to 8. After removing the brackets, we have 1 minus d square is equal to minus 8. Therefore, 1 plus 8 is equal to d square. Therefore, d square is equal to 9. Taking square root on both the sides, we get d is equal to plus or minus 3. Now put a is equal to minus 1 and d is equal to 3. We have t1, that is first term, is equal to a minus d is equal to minus 1 minus 3, which is equal to minus 4. Similarly, t2, that is the second term, is equal to a, which is equal to minus 1. Also, t3 is equal to a plus d, which is equal to minus 1 plus 3 is equal to 2. Therefore, the three consecutive terms are minus 4, minus 1 and 2. Similarly, putting a is equal to minus 1 and d is equal to minus 3, the three terms obtained are 2, minus 1 and minus 4.
Question number 7. Babu Bhai borrows rupees 4,000 and agrees to repay with a total interest rupees 500 in 10 installments, each installment being less than the preceding installment by rupees 10. What should be the first and the last installment? Solution. Each installment is less than preceding installment by rupees 10. Therefore, the installments are in arithmetic progression with a common difference minus 10. Babu Bhai agrees to repay rupees 4,000 with a total interest of rupees 500 in 10 installments. That is, S10 is equal to 4,000 plus 500. Therefore, S10 is equal to 4,500. Here we have n is equal to 10, d is equal to minus 10 and S10 is equal to 4,500. We have to find the first installment, that is A, and the last installment, that is T10. Sn is equal to n upon 2 in bracket 2a plus n minus 1 into d. Therefore, S10 is equal to 10 upon 2 in bracket 2a plus 10 minus 1 into minus 10. Therefore, 4,500 is equal to 5 into 2a plus 9 into minus 10. Therefore, 4,500 is equal to 5 into 2a minus 90. 4,500 divided by 5 is equal to 2a minus 90. Therefore, 900 is equal to 2a minus 90. Therefore, 900 plus 90 is equal to 2a. Therefore, 2a is equal to 990. A is equal to 990 divided by 2. Therefore, A is equal to 495. Now, T10 is equal to A plus n minus 1 into D, which is equal to 495 plus 10 minus 1 into minus 10 is equal to 495 plus 9 into minus 10, which is equal to 495 minus 90. Therefore, T10 is equal to 405. Therefore, the first installment is rupees 495 and the last installment is rupees 405. Vijay invests some amount in the National Savings Certificate. For the first year, he invests rupees 500. For the second year, he invests rupees 700. For the third year, he invests rupees 900, and so on. How much amount he has invested in 12 years? Solution. It is given that for the first year, Vijay invests rupees 500. For second year, rupees 700. For the third year, rupees 900, and so on. Therefore, the investment for each year, that is 500, 700, 900, and so on, are in arithmetic progression. With the first term, A is equal to 500. Common difference D is equal to 700 minus 500, which is equal to 200. It is also given that Vijay invested for 12 years. Therefore, N is equal to 12. Now, to find the total amount invested in 12 years, we have to use the formula Sn is equal to n upon 2 into, in bracket, 2a plus n minus 1 into d. Therefore, S12 is equal to 12 upon 2 into, in bracket, 2 into 500 plus 12 minus 1 into 200, which is equal to 6 into, in bracket, 1000 plus 2200. Therefore, S12 is equal to 6 into 3200, which is equal to 19,200. Therefore, Vijay invested rupees 19,200 in 12 years.